All right, today's lesson is 6.1 and 6.2. This is chapter 6, which is electric energy at home. So, generating electric energy is our first topic. So, just imagine your life without any light bulbs or television or CD players or video games. So, we use electric energy every day, not only for fun, but for basics like light and heat. And the way we use electricity has changed the way we live. It's hard to imagine life without it. In Alberta, the energy that we use to light up our rooms at night usually come from the potential energy in a lump of coal. And basically what happens is that energy from burning coal, it turns a generator, which in turn produces electricity. We'll take a look at that a little bit more. The potential energy in coal is basically being converted to electric energy. So here we have Michael Faraday, and in the early 1800s, he started investigating the magnetic field around magnets. And he found that pushing a magnet through a coil of wire generated an electric current. And when he added more coils, or by using a stronger magnet, it produced more electric energy. So using these observations, he made the first electric generator, which is a device that makes electricity. And here's just a little bit history of him. He was the son of a blacksmith, received little formal education. While apprenticed to a bookbinder in London, he read books on scientific subjects and experimented with electricity. And in 1812, he made notes as he listened to the British chemist Sir Humphry Davy. He sent the notes to Davy, asked for a job. Davy hired Faraday as a laboratory assistant. And today, Faraday is probably better known than Davy because of these observations. So we'll take a quick look at a couple videos here on how magnets produce electricity, as well as electromagnetic induction and force. I just want to finish this last slide as well. So generating electricity. So a generator, it's one device that produces electricity. The two main parts are a magnet and a coil of wire, for example, like copper wire. And moving a wire coil through a magnet field produces electricity. And it can work when either the magnet or the wire coil move. And making the huge amounts of electricity that we need today involves gigantic generators. So here in this diagram, we can see a generator consists of a magnet and the coil of wire. Spinning the coil of wire through the magnetic field is one way to generate electricity. So the next part of today's lesson is 6.2, which is generating and distributing electric energy. So most electricity, like we saw, is made in a generator, and these generators contain one or more turbines. So a turbine, it's a set of blades put at an angle so that they can collect energy from fast-moving water or steam or wind. And in order to make electricity, turbines need to be connected to a generator. So then as the blades of the turbine turn, their kinetic energy is transformed into kinetic energy in the generator, and that is what produces electricity. So here in this figure, we have a turbine generator. It's a combination like this. And so they have a set of these blades right here, adjusted to the correct angle to collect the most amount of energy from fast-moving water, steam, or wind. So here in part A, we have moving water or steam at high pressure. It's focused onto these turbine blades and it starts to turn the machine. So it's turning here. And then at B, the water or the steam will leave the system. And then C, this is the generator. So this turbine is attached to this generator. And as this turbine turns, the kinetic energy of that spinning turbine is transformed into kinetic energy in the generator. And that in turn will then produce electricity. So there is a video here on electricity generation looking at turbines. We'll watch that in a second. This figure here This first one is a hydroelectric plant. It's going to convert the kinetic energy of moving water, such as water falling over a dam or a waterfall, and it's going to convert that into electric energy. Here is a thermoelectric power plant. It converts chemical energy in fossil fuels, for example, and this energy gets converted to thermal energy, then to kinetic energy, and then to electric energy. This is a thermonuclear plant, and it's splitting atoms, usually uranium, which will release thermal energy that's converted to kinetic energy and will then be connected to electric energy. Let's take a look first at a coal-fired thermoelectric generation plant. So these use the fuel that is cheap and plentiful. For example, in Alberta, coal is cheap and plentiful in Alberta. Keep in mind that in modern thermal plants, smoke from the burning coal is put through scrubbers, and they basically remove the harmful chemicals from the smoke before it gets released into the air. And we did talk about that in Unit 1. So here we have a diagram of a coal using coal for electricity. So again, a coal-fired thermoelectric plant, and this is what's usually used in Alberta. And so you got lumps of coal in part A, which are broken down to a powder, which is then blown into a combustion chamber right here. And the reason we turn this into powder is that so that coal will burn rapidly and efficiently. In the furnace then, thermal energy from the burning coal converts water into steam, which we can see kind of happening right here. And then here we have the steam turbine. So that steam flows through pipes and onto the fan blades of this turbine. The turbine will start to spin with kinetic energy. D, we can see that the turbine is connected to the generator, and it's going to start turning that generator. The generator is going to convert that kinetic energy of movement into electric energy. And E, the steam will eventually leave the turbine. It'll enter a cooling chamber, which is right here. And what happens there is the steam gets condensed back to liquid water and gets returned to the furnace. That way it gets reused over and over again. And the electricity is distributed to customers by transmission lines. Advantages and disadvantages of using fossil fuels. We did talk about this in Unit 1 already as well. Advantages, it's inexpensive, and Alberta and other regions of Canada are well supplied with fossil fuels. Disadvantages, it produces those greenhouse gases, it produces carbon dioxide, sulfur dioxide, and those gases can lead to acid precipitation. Supplies of fossil fuels are limited, cannot be renewed, and also mining and processing operations will also damage the environment. All right, next is electric energy from water. So this is hydroelectric power plants produce much of the electric energy in Canada. It uses the kinetic energy from falling water to generate electricity. So for example, large dams are built high above the generating station. It's a clean and efficient way to generate electricity. Once the facilities are built and working, there's usually little environmental damage, and there's no harmful emissions being released into the atmosphere. The generators will run with little maintenance. The main disadvantage of hydroelectric power is that the generating stations require large dams, and then these large dams produce large lakes or reservoirs that can flood land and change the ecology of an area. So also affecting ecosystems. Okay, there is a video here on hydropower. There's the link. Next, we're going to look at the thermonuclear generating station, so energy from splitting atoms. So it's usually uranium atoms are split by nuclear fission. And this splitting releases a tremendous amount of thermal energy, and that thermal energy will then be used to make steam. the steam will then turn a turbine. So here we have an example. This is a CANDU nuclear reactor built in Canada, also used in Argentina, India, South Korea, Pakistan, and Romania, as well as some are being built in China. Okay, so part A, there are uranium fuel rods that get inserted into the reactor core and nuclear fission will begin. In part B, the fission reactions produce a lot of thermal energy. That energy is carried away from the reactor by a coolant. In the coolant tank, thermal energy converts water into steam. The steam will flow through pipes and gets directed to this to the blades of the turbine, and the blades will start to move and spin. The spinning turbine is connected to the generator. The generator converts that mechanical energy into electric energy. And finally, F, the transmission lines will take that electric energy to customers. Advantages and disadvantages. So advantages, there's no harmful gases like carbon or sulfur dioxide being released. Also, a small amount of this nuclear fuel will generate an enormous amount of electricity. Disadvantages is that nuclear waste is very dangerous to life for centuries. The storing of that waste safely is expensive and dangerous, and if there's any accidents, it can release radioactive materials which can kill plants and animals, and it can also cause illnesses that show up years later. All right, and lastly, we'll talk about distributing electricity and then solar cells. So electric generating plants are usually located great distances from the communities, and then electricity has to be transmitted hundreds of kilometers along power lines. And as electricity is passing through these lines, about 10% is converted to thermal energy and is just wasted. So these thermonuclear plants and thermoelectric plants that burn coal are often located closer to cities, which will lessen power loss, but it does create environmental concerns. In Canada, those long transmission lines can also cause other problems, like heavy storms can knock down the power lines, and in some cases, that damage can take weeks to repair. And lastly is just solar cells or solar power. It just shows that there are other ways to make electricity. One way is solar power, and these solar cells can convert the sun's energy into electric energy, and this energy can then be used immediately or it can be stored in batteries. You've probably seen some solar panels on lawn lights, some calculators, electric fences, and even the International Space Station uses solar panels. So there is a video link here for you to watch as well on solar power. And then these are just the questions for 6.2.